Welcome dear students to this video. Today we discuss about heterocyclic compounds, which is part of module 7 in organic chemistry. Today we have an introduction of heterocyclic compounds. We will discuss what is the difference between homocyclic and heterocyclic compounds, the important heteroatoms which occur in heterocyclic compounds, that is nitrogen, oxygen, sulfur, classification of heterocycles, and also the nomenclature. Homocyclic compound means cyclic compounds or ring compounds which can only carbon. For example, we know what is this cyclohexane, which is an alicyclic compound. There are 6 carbons. What is this? This is benzene, which also contain only carbon in the ring. But at times heteroatoms, like what is heteroatom? Atoms other than carbon. Nitrogen, oxygen, sulfur, phosphorus, arsenic, boron. These elements can come in the ring, part of the ring. Then it is called heterocyclic. So cyclic compound which contain atoms other than carbon in the ring. For example, instead of carbon, if I put nitrogen here, what is this compound? This is called pyridine. Okay, which is a heterocyclic compound. Now we'll go to more examples. Classification. Which is the smallest ring which can be formed? It's a 3-membered ring, but it is very unstable, due to ring strain. So 3-membered ring, 4-membered, 5-membered, 6-membered, 7-membered. There are many types of ring compounds, but more stable ones are 5-membered and 6-membered, which is more common and more stable. So we'll consider 5-membered, 6-membered rings, and also fused rings. Means 2 rings are sharing sides. Condensed system we call. So classification of heterocyclic compounds, here we have 3 types: 5-membered heterocycles, 6-membered heterocycles, and fused or condensed heterocycles. We will get familiar with a few examples, during which we will consider the nomenclature also. Before we go to examples, what are the important points to be noted in nomenclature? One is that for the heteroatoms like oxygen, nitrogen, and sulfur, we use the terms oxa for oxygen, aza, aza for nitrogen, and thia for sulfur. Then point 2, when it is a 5-membered ring, the name should end, or the suffix is ol, O-L-E. When it is 6-membered ring, it is I-N-E. And for fused system, what we do is, we prefix the ring like benzene or naphthalene as benzo or naphtho to the parent name. Okay, keep this in mind while going to examples. Let us go to various examples of heterocyclic compounds. Remember that our syllabus emphasized 3 particular compounds to be discussed in detail. One is this furan, which is a 5-membered heterocycle, furan, oxygen containing heterocyclic compound. Another is pyridine. It's a familiar one, 6-membered ring with nitrogen. And then in fused system we have an example, that is indole, which can also be called benzopyrrole. Benzene ring is there and pyrrole is there. These are the systematic name. We will come to that in due course. Let us go to various examples under these categories. Okay, first of all, 5-membered ring, which can be again divided into 2. that is 5-membered ring containing only one heteroatom or more than one. Right. Let's go to examples. In 5-membered ring containing only one heteroatom, let us take a few examples. If it is nitrogen, there will be H here to meet up the valency, and we have a lone pair now on nitrogen. What is this called? This is called pyrrole. This is pyrrole. Okay, that is a common name. In IUPAC system, for 5-membered ring we have to end with ol, and it is nitrogen, so it is simply called azole. This is the systematic name, azole. But mostly in heterocycles, like in many other cases, common name is more popular, more often used. So this is commonly called pyrrole. Okay, so the naming is a little bit liberal in here. You can name different way. Then if it is oxygen, it is here. What is it? It is furan, common name, and systematically it is to be called oxole. Oxo. So it is oxole. Next one, 5-membered ring is sulfur compound. Instead of oxygen, if it is sulfur, this is called, it can be called thiol, and the common name is thiophene. Thiophene. Okay, so thiophene or thiol. So these contain only one heteroatom. Now this heterocycles, these are all unsaturated, even they are aromatic. If you hydrogenate, add hydrogen, this becomes saturated. We don't have that discussion, but still one example. The name will be different now. It is now called pyrimidine. I am mentioning it because when we learn alkaloids, alkaloids, these names will come. Okay, one point regarding the importance of heterocyclic compounds. What is important? Heterocyclic compounds are biologically very important. They occur in proteins, right? In many amino acids, there are heterocycles, and very important in nucleic acids, purines and pyrimidines are heterocyclic compounds. Then alkaloids are also nitrogen containing heterocyclic compounds, okay, mostly. Then coming to the next one, 5-membered ring with more than one heteroatoms in the ring. Let us take a few examples just to understand, just to get familiar with the examples. We don't have detailed discussion. So 5-membered ring with more than one heteroatom. Look at this example. I am putting one more in here. Okay. What is this called? This is called 2 nitrogen, and it is pyrazole. Okay, this is called pyrazole. Right? Systematically, it can be called, putting 1 and 2 numbering, 1,2-diazole, because it is azole basically, and there are 2 nitrogen, so it is diazole. Now there is some position isomers here. Nitrogen, if it occur here, nitrogen can be here also, right? Then it is called imidazole. That's the common name, imidazole. So pyrazole, imidazole, right? What is the systematic name then? It will be 1 and 3. So 1,3-diazole, like that. Now look at this one. 2 different heteroatoms. Suppose oxygen here and nitrogen here. Okay, this one. This is called what? Here, when there are 2 different heteroatoms, numbering is based on the rule that priority is given to elements coming in higher group in the periodic table. That means group 16 is preferred over 15. So oxygen is preferred over nitrogen. So numbering start from here, 1, 2, 3. So what is the systematic name? 1, 3. This is oxa and aza. So oxazole, it is called oxazole. Okay, oxazole, or simply oxazole. If it is sulfur, it is called thiazole. If it is sulfur instead of oxygen, suppose it is sulfur, okay, right in here, what is it called? Thiazole. Okay, that's about 5-membered rings. Now we can go to 6-membered rings. Okay, in 6-membered ring, first of all let us discuss examples for 6-membered ring with only one heteroatom. Okay, this is the first example. Pyridine, I told you, it is systematically called azine, commonly pyridine. Instead of nitrogen, if it is oxygen here, then double bond will be coming only here. Okay, what is this called? This is called the Piranha. Okay, that's the common name. Systematically, it has to be called what? According to this, oxa and in. So oxine. It's to be called oxine. So this is Piranha. But here there is an isomer for this one. Like, see, oxygen here, and I change the double bond position, and now it is here. This is also Piranha. Then what's the difference? So we number from here. If it is numbered as if it is, I mean, in the common method, with respect to oxygen, this is alpha carbon, beta gamma. So this is called gamma Piranha, and this is called alpha Piranha. Another method is indicate the point of saturation. See, this is a saturated carbon, correct? sp3 carbon, saturated. So instead of gamma, okay, instead of gamma we can put, this is position 1, 2, 3, 4. So position 4 is saturated, we indicate by putting 4H. 4H Piranha, that is another way of naming it. Okay, different ways. So this is Piranha, okay, and if it is sulfur, instead of oxygen, if it is sulfur, this is called thiopyran. Thiopyran, okay. Now coming to examples for 6-membered ring with more than one heteroatom. Let us take a few examples, which are familiar or which we come across in some other modules also. Suppose let us take 6-membered ring with 2 nitrogen. Okay, this is one, and I am keeping one other nitrogen here, like this. What is this called? This is not pyridine, it is, and a name end with ine, so it is pyridazine. See, pyridazine. So pyridine and azine together, 2 nitrogen, so pyridazine. What is the systematic name? This is a common name. Systematic name will be numbering from 1, 2. So it is 1, 2. What? Tell me. Azine. It is azine, 2 nitrogen, so diazine. You understand? 1, 2 diazine it is. Changing the position of nitrogen, you get another isomer. There is nitrogen here and here. Okay, you know this one? This is familiar to you. This is what is pyrimidine. Pyrimidine. Okay, this is called pyrimidine. Right? Now, if it is this is 1,3, actually systematically can be called 1,3 diazine. If it is 1,4 position, nitrogen here and here, okay, it is what 1,4 diazine, or commonly called, it is called pyrazine. This is pyridazine, this is pyrimidine, and this is pyrazine. Okay, pyrazine. Let me check it. Yeah, correct. So these are the examples. Fine. Okay. Now we move on to the last one. Okay, this much is enough for us, our discussion. The last one, condensed system. One example is over here. Let me check whether I mentioned this one. See, coming back to this 5-membered, I just wanted to check whether I mentioned this or not. If in 5-membered 2 nitrogen occurring here, if it is here, we said it is what? It is pyrazole, isn't it? At these 2 positions. And if it is here, what is it called? This is 1,3-diazole. 2 nitrogen and it is 5-membered, so it is diazole, 1,3-diazole. What is the common name, you know? This is called imidazole. I don't know whether I mentioned. You just note that this is imidazole. It's also a very important heterocyclic ring. Okay. Finally, to the last one, that is condensed system. See, look at this. This is commonly called indole. In systematically, what we do is, this is the parent, that is pyrrole. That's a heterocyclic ring, and to which benzene is fused or condensed, sharing the site. So what we do is, we prefix this as benzo and say pyrrole, benzopyrrole, or it is commonly called what? It is commonly called indole. Putting some other examples, instead of this one, if it is furan, for example, like this, what is the name? Yeah, how we call it? Benzofuran. That's the name used for this one, benzofuran. Okay. Now look at this one, interesting ring here, that is like this. That is nitrogen here. What is it? This is benzo, benzene fused to what? This is what? This is pyridine. So we can call it benzopyridine. Okay, but it is popularly known as, you know this, quinoline, a very important nitrogen ring compound. Quinoline. This has a position isomer. Changing nitrogen to this position, you get a position isomer for quinoline. You know what is it called? Nitrogen is placed at this position. Okay, so what is the name of this one? This is called, just we prefix iso. So what is it? Isoquinoline. So quinoline and isoquinoline. Finally, we have another example. It's interesting, again a very important ring system. Look at this. Nitrogen here, nitrogen here. So what is it? There will be a hydrogen to maintain the valency. This is imidazole, and also nitrogen at this position. What is this one? This one singly taken. We already discussed this one. 2 nitrogen at 1,3 position. What is it? This is called this is called pyrimidine. Did I say that? Pyrimidine. I told you, pyrimidine. So this is actually a combination of pyrimidine as well as, what is the importance of pyrimidine? It is part of the DNA, isn't it? And RNA, nucleic acids. So it is pyrimidine and imidazole together. This is what is purine. You know, purine and pyrimidine bases, the nitrogen rings compounds present in the nucleic acid, isn't it? That is adenine, guanine, thymine, uracil and cytosine, which are purine and pyrimidine bases. Purine is this one, containing, it's a fused system, 2 rings are there. And this alone is pyrimidine. Together with imidazole, it is purine. You can remember that way. So that's all about the introduction of heterocyclic compounds. We will discuss and detail the chemistry of 3 compounds, furan, pyridine, as well as indole, that in the coming videos. Till then, bye.